This will be for the con assignment arc length. So all of these are going to be in degrees for the central angle. So an arc is a piece of the circumference of the circle. So the circumference of the circle is the distance around. An arc is just a piece of that distance. So the arc length is the length of this curve right here. Imagine the crust on a slice of pizza. That would be like an arc. This is the center of the circle right here. And the angle that is made is called the central angle. It is represented by the Greek letter theta. All right, so if I were to make a ratio and proportion for the angles and the arc length, let me see here. So for the angles, we said the central angle is represented by the Greek letter theta. Okay, so that's our central angle. And if we measured the central angle all the way around the circle, that would be 360 degrees. Okay, remember for this one, we're dealing with degrees. All right, and the arc length is a piece of the circumference. It's represented by the letter S. So the piece is S. And the arc length of the whole circle is considered the circumference. That's the distance around. So this is going to be C right here. So we're going to be using this ratio and proportion to solve these problems. So it says a circle has a circumference of 6. It has an arc length of 17/3. What is the central angle of the arc in degrees? All right, so we're going to use this ratio and proportion. The central angle is theta. That's what we're looking to solve. So we don't know that yet. And the angle all the way around the circle, that's 360. Okay, S is the arc length. It said arc length is 17/3. And the circumference, it said, was 6. Okay, solving for theta, we just multiply both sides by 360. All right, so times 360 right here, times 360 right here. Okay, on the left-hand side, 360 over 360 cancels. 360 divided by 6, let's see, 36 divided by 6 is just 6, and then we can just add the 0. So 360 divided by 6 is 60. Okay, and this is a numerator, this is a denominator, so 60 divided by 3 is 20. Okay, and then 17 times 20 is going to give us 340. So that is in degrees. So just enter 340 in the box. All right, if you want to look at the drawing to see if your answer makes sense, okay, recall 360 is all the way around the circle. So it would make sense that this angle right here is a little less than 360. All right, so once again, we're using our ratio and proportion. Theta over 360 equals S over C. All right. So let me see here. It says the radius is 3. All right, we're going to deal with that later. It says the central angle is 340. And they want to know the length of the arc. That's S. Okay, so in place of the central angle, we'll enter 340. We have 360 in the denominator. We are solving for the arc length S. And the circumference C we can find from the radius. If you recall, the formula for circumference is 2 times pi times r, okay? It says in the problem that r is 3. So that's going to be 2 times pi times 3, okay? Now for these, your best bet is to leave pi alone, okay? Because it says enter an exact answer in terms of pi or use 3.14 for pi. But that's going to be extra work to use 3.14, so let's leave it as pi. So 2 times 3 is 6, and we still have pi. Okay, so that is our circumference, C. And we are going to replace C with 6 pi. Okay, so we have S divided by 6 pi. In order to solve for S, we're going to multiply both sides by 6 pi. Okay, on the right-hand side, 6 pi over 6 pi cancels. On the left-hand side, this is a numerator, this is a denominator. So 360 divided by 6 is just 60. Okay, so we still have the pi here. This is 340 over 60. Okay, we can divide top and bottom by 10 and cancel the 0. So that's 34 over 6. Those are both even numbers. So divided by 2, 34 divided by 2 is 17. 16 divided by 2 is 3. And we still have pi. So S equals 17 over 3 times pi. That's going to be 17 thirds pi. Now the way to enter this in the box, first type 17/3, and it gives you the fraction, and then hit the right arrow key because you don't want to enter pi in the denominator. So either click to the right or just hit the right arrow key, and then click pi, okay? Or you can just type pi, and it will give you pi. That's 17 thirds pi. Okay, here it says a circle with circumference 10 has an arc with a 162 degree angle, and they want the length of the arc. All right. So same ratio and proportion for all of these. Theta over 360 equals S over C. All right. So theta is our central angle. Okay, that's 162 in place of theta. Divided by 360. The length of the arc is S. That's what we're solving for. And the circumference is 10. So that's in place of C. Okay, so this is S divided by 10. Solving for S, just multiply both sides by 10. Okay, on the right-hand side, 10 over 10 cancels. On the left-hand side, you can use the calculator if you want, but I know 10 divided by 360 divided by 10 is going to give us 36. And let me see here. Really, the calculator is best for this because it works out to 4.5. But I can tell that both of these are divisible by 3. And the reason I know that, 1 plus 6 is 7 plus 2 is 9. So this is divisible by 3. Let me see. 3 into 162 is going to be 54. And 3 into 36 is going to be 12. Okay, 54 divided by 6 is 9. 12 divided by 6 is 2. So we're left with S equals 9 over 2. And you can just enter that in the box as 9/2 or 4.5. Okay, we basically just did this one, except we're solving for a different number. So I already know the answer is 162. But let me just go through the process. Okay, theta over 360 is going to equal S over C. All right. So we're looking for the central angle. That's going to be theta. And that's over 360. S is the arc length. That's 9/2. So in place of S. And then C is the circumference. That's 10. Okay, solving for theta, multiply both sides by 360. On the left-hand side, it cancels. On the right-hand side, 360 divided by 10 is 36. Okay, and this is a numerator. This is a denominator. 36 divided by 2 is 18. Okay, and we're left with 9 times 18. Well, I know 10 times 18 is 180. Minus 18, that's going to give us 162. So just enter 162 in the box. Okay, so just remember to use this ratio and proportion for all the problems in this section.